Alright, so in this video, we're going to be discussing topic 4.1, which is going to be called as Radian Measure. So we are now on chapter 4, and chapter 4 is going to be the introduction to trigonometric functions, because later, remember, chapter 4, 5 and 6, everything is going to be in terms of trigo, and chapter 4 will be the introduction part of the trigonometric function. Okay, first of all, we're going to discuss about radian measure. So you know what an angle is. So angle is the shape formed when two rays come together. So rays is basically a line. So here I have two lines, O, R2, that's my first line. From O to R1, so that is going to be the second line. So the angle is going to be the shape formed in between the two rays. So this is the shape formed in between the two rays. So that is going to be called as being the angle. Okay, so there are two type of angle. Not really two type of angle. So angle can be positive and it could also be negative. So how do you classify whether it's going to be positive or negative? So there are a way of like whether it's going to be defined as being a positive angle or it's going to be defined as being a negative angle. Right, for the case of positive angle, so what happened is that it's going to, so this is going to be the what do you call that, the origin, so where it starts. Okay, and when your function actually goes anti-clockwise, so anti-clockwise means the the clock direction is called as anti-clockwise, the opposite of clock direction, your angle is going to be a positive value. So here I started over here and end somewhere over there, so I actually end moving anti-clockwise, opposite the clock direction. So I know that this 120 is going to be a positive 120 degree. Okay, and the same the opposite idea will be applied for the case of negative angle. So this axis is still going to be our origin, so this line over here, so this is going to be where we start, but when we go clock direction, so this is called as being clockwise. So clockwise means clock direction. So what happened is that your angle is going to be a negative value. So this is 120, so that's the magnitude, the value of the angle, but this is actually a value of negative 120 degree. So that is the difference between positive and negative angle. And actually some of them could be the same. So what do I mean by some of them could be the same? For example, let's say if I have a function of so here somewhere over here, so let's say this is going to be my 45 degree, so it could be equivalent to me moving that way. So this is going to be the same angle. This is going to give you the same value, and this angle, because it's moving clockwise, so it's going to be negative value. So this is actually an angle of negative 315 degree. And if you use your calculator, so what happened is that, so the value of from negative 315 degree, it's going to be exactly the same as the value of 45 degree. They are equivalent, they are the same. Okay, so that is the case of positive and negative angle. And of course, I'm pretty sure you know this already, that for the case when you use degree as your unit, so one complete circle, so starting from here and end up until there, so one complete circle is going to be 360 degree. So here this is going to be 0 degree. So let me put 0 properly. It looks like theta right here. So this is my 0 degree, this is my 90 degree, this is 180 degree, and this is going to be 270 degree. And of course at the end, when you have one full rotation, so that is going to be 360 degree. Okay, angle has its name, so there are different type of angles, and it's going to be different according to the angle itself, the value of the angle. So if you have an angle that is less than 90 degree, so meaning that it's going to be 90, below 90, 45, 30, 60 and so on, so it is actually known as an acute angle. Okay, and when you have it at exactly 90 degree, and an angle that is exactly 90 degree upright, so that is called as being a right angle. Okay, and if you have anything that is greater than 9 but less than 180, like what I have over here, for example, it could be 100 degree, 120 degree, 115 degree, so it's called as being an obtuse angle, as long as the value is between 90 and 180. And then when your angle is exactly 180 degree, it's called as being a straight angle. And any angle that is greater than 180 but is less than 360, it is called as being a reflex angle. And of course, if it's exactly 360 degree, it is called as being a full angle. So this is going to be the name. So that sometimes when you come across in the question, so it says that this is an acute angle, you know right away what happens is that when we have an acute angle, so the angle is supposed to be a value that is less than 90, and it's going to be in the first quadrant. Okay, now we're going to talk about a radian measure. So it says over here, so basically what is a radian measure? Radian measure is basically just theta. Okay, so the thing about when you have an angle is that, so there are two units that you can use for angle. So the thing that we're most familiar with is going to be degree, okay? And so this represents degree. Let me put over here, so that is not 0. And the second unit that you can use is going to be called as the radian unit. It's simply the same like, let's say I'm talking about height, okay? So if I talk about my height, so my height is 152 centimeters. I know it's kind of short. And I can actually express it as meters as well. I can say that I am 1.52 meters. So it's just a matter of different units. So one is going to be centimeters, one is going to be meters. So that will be the same for degree and radian as well. So they are actually talking about the angle, but the unit is different. So one is going to be in terms of degree unit, so the other one is going to be in terms of radian. And even when you press your calculator, you have to specify, so whether you wanted, for example, if you put sine at 30, so the calculator has to know whether you're referring to degree or you're referring to radian, of course, but you put a 30, so it should be in terms of degree because it's too large of a number for radian. But remember, when you want to use radian for your calculator, you have to change the mode and make it into radian. I think by default it's going to be in degree, but when you want to use radian, you have to change the mode. Okay, so let's have a look at the definition of radian measure. So if we place the vertex of the angle at the center of a circle of radius r, okay, so this is going to be our vertex. So we put it at the center of a circle, and here we have a radius r. I'm pretty sure you know this already. Like, what is the difference between radius and diameter? So let's say if I have, this is my circle. I know it looks hideous. It doesn't even, like, it's not really a circle, but you get the idea. So if from the center, so to the end, so this is called as being the radius. So this is our radius. So usually it's denoted by r. And if you have complete over here, so complete means like 2 times the radius from one end to the other end here, so this is called as being the diameter. So twice the radius, so that is called as being the diameter. So let us denote the length of the arc intercepted by the angle. So this is our angle. So whatever the length which is between the angle, so this is our line, so this is the first line, this is second line. So the distance that is formed, the arc that is formed between the two lines, so that is called as being the arc length. Okay, so that's the name. It's basically it's actually just the length from one ray until from one line from the second line. So the radian measure theta is the angle is the ratio of the arc length s to the radius r. So in symbols, so theta is equal s over r. So what is s? So according to what's written over here, s is going to be the arc length. Okay, so it's going to be arc is called as lengkung. So it's the lengkung. Okay, jarak lengkung. So that is why it's called in Malay. For the s, it's represented by s, and r is of course the radius. So if you have the value of the s, you have the value of the r, so you can find what is going to be theta. But however, let me warn you about the theta. So the theta over here is going to be in radian. When you use this formula, so you have to make sure that your theta is in terms of radian. You cannot use it in terms of degrees. So that's the condition. Okay, or if you have theta and r, you can also find what is going to be the value of s. So as long as you have two of those values in the formula, automatically you can find the other one. Okay, remember, so theta, the angle is equal the arc length divided by the radius line. So here it says determine the radian measure of each angle. So this is going to be an example. So here I wanted to know what is going to be the theta, and we have seen before that the formula is theta is equal S over R. So for this case, what happened is that the length between these two lines formed by the angle is actually have an arc length of 5 centimeter. Okay, and the what do you call that, and the radius on the other hand is given by a value of 2, so 5 divided by 2, that is going to be radian. Again, remember when you use this formula, so the theta that you get is going to be in terms of radian. However, before you start doing the calculation, so you have to make sure that both of the S and the R, they have the same unit. So actually, student would ask me, in mathematics, is it necessarily to change to SI unit? So the answer is no. So you used whatever unit that we gave you, except for the angle. So most of the time, angle, it should be in terms of radian. So that actually applies for this formula right here, for which when you come across something in degree, you have to change that to be in terms of radian. But other than that, when it comes to meters, when it comes to centimeters, gram or kilogram, so just use whatever unit that is already given in the question. So don't bother to change them. So I know that in physics, it is really important for you to use SI unit, but in maths, it's completely different. We don't actually need you to do that. So simply use the unit given. Okay, however, for the second example, we have a problem right here, because my radius is given by 1 meter, and the arc length is given by a value of 200 centimeters. So the idea is that you can use either unit, so you can change centimeter to meter or meter to centimeters, because we know that this is going to be 100 centimeter, or we can also convert this to become 2 of meters. So either you use meter or centimeter, so it's going to give you exactly the same answer. Okay, so for this case, what happened is that my S value, so that is going to equal, so if I'm using meter over here, so 2 meter, so divide by R, which is given by 1 meter, so I will get that my theta is given by 2 radian unit. So remember, the theta we get from the formula is going to be in terms of radian, so that is why it's called as radian measure, not degree measure. Okay, now let's have a look at a relationship between degree and radian. As I told you, both of them are unit to represent angle. Okay, they're just different of unit, but they actually talking about the same thing, which is going to be the angle. Alright, so according to definition, so what happened is that 180 degree is equivalent to pi radian unit. Okay, so basically, if I have what do you call it, an axis like this, so this is my 0 degree, so 0 degree is equivalent to 0 radian. But for the case of 90 degrees, so this is equivalent to pi over 2 radian, because 180 degree is actually equivalent to pi radian. Okay, and of course 360 degree, no, 360 degrees is going to be somewhere on this side. This is not 360, so that's wrong. So this is actually 270 degree, but my 360 degrees is going to be right here when I complete the whole circle. So what happened here is that through 170 degree is actually equivalent to pi plus a half, so which is going to be 3 pi over 2 radian, and 360 degree is equivalent to 2 pi radian. But usually we don't really use radian, so we just tell that it's going to equal 2 pi, and right away we know that it's going to be in terms of radian. And most of the time when something is talking about angle and they use pi, automatically we have to know that that is actually going to be in terms of radian, because if it's in terms of degree, so degree is going to be written. Okay, so that is why, so we can use degree and radian interchangeably. So we can change radian to degree, degree to radian, and so on. So 1 radian, okay, so according to this equation, pi radian is equal 180 degree. So if I wanted to find what is going to be 1 radian, so that is equivalent to 180 degree, so divide by pi, so that will be the formula. Okay, and the same goes for 1 degree, so 180 degree, so that is equivalent to pi radian. So 1 degree is going to equal pi over 180 radian. Okay, so I have a way of remembering this. So the way I remember this is that whatever that you're going to cancel, one is going to be at the top, one is going to be at the bottom here. So I need to cancel radian, so at the bottom is going to be radian. So I need to cancel the degree, so at the bottom is going to be in terms of degree. and it's either going to be pi or it's going to be 180 degree, because remember, so pi radian is equivalent to 180 degree. So this is like the equivalence of them. So pi over 6 is actually 30 degree. So pi over 4 is actually 45 degree. If you notice, it's not the unit is not written. Pi over 4, it doesn't write pi over 4 rad, no. So if we're talking about angle, the unit is not given automatically. It's going to be in radian, because if it's degree, it's going to be written as 45 degrees, 60 degree, 90 degree, and so on. Okay, so now we're going to start changing the units. So here, so the easiest way, if you couldn't remember how to do it, just write that pi radian is equal 180 degrees. So with this equation, so you can start finding like what happened when you have degree to change to radian and radian change to degree. So if I have 60 degrees Celsius and I want to change that in radian, as I told you before, so here I need to what do you call that, cancel the degree. I'm going to put 100 degree at the bottom, multiply that by pi over 100 degree, so I will get pi over 3 radian. Because remember, so 1 degree, so according to this equation, 1 degree is going to equal pi over 100 degree radian. Okay, and then so here I have radian. I want to change it to be in term of degree, so therefore I'm going to have to multiply that by 180 degree divided by pi, so that is converted to 30 degree. Remember, so if you want to change what do you call it, if you want to change from radian to degree, so you multiply that by 180 over pi. So when you change from degree to radian, it's going to be pi over 180 degree. Okay, now let's talk about the formulas for length and sec